Hello, in this video I will give a quick explanation on probability of combined events, and they are mutually exclusive events, independent events, and dependent events. Okay, a probability of combined or compound events is a probability that consists of two or more simple events. Now, in the next slides, I will show you about the rules of combined events. Yeah. Okay, let's start off with independent event. Yeah. Suppose we have event A with probability half and event B with probability 1 over 3. Again, they are independent events. Then suppose that there are 60 equally likely outcomes represented by this dot here. Okay. Then, knowing the probability of event A is equal to half, therefore we can label half of the sample space with A's. Yeah, remember the probability of event A to occur is equal to half. Therefore, half of these has to be A's. Similarly, the probability of event B is equal to 1 over 3. Therefore, 1/3 of this sample space belongs to B or equal to B. Yeah. So there are 20 B's and 30 A's. Remember, the entire dots is equal to 60, right? So there are X's here that indicate both A and B occurred. So you can say that X is belong to A and event B. Okay, then the next question is, how many times did X or both occur? Well, if we look at this part here, yeah, the answer is 1 over 3 of the half, which is 1 over 6 of all outcomes. Similarly, likewise, if we look at this part here, okay, X is half of 1/3, okay, because B's or event B is occupying 1/3 of the sample space. So half of 1/3, which is also equal to 1 over 6. Therefore, the probability that A and B occur is 1 over 2 multiplied by 1 over 3 is equal to 1 over 6. That is 10 over 60 in this picture here. That is why for independent event, the probability of event A intersection event B is equal to the multiplication or product of probability of event A and the probability of event B. Okay, let's continue to dependent event probability. Here we have 3 blue marbles and 7 green marbles. Therefore, the probability of selecting a blue marble is equal to 3 over 10, and the probability of selecting a green marble is equal to 7 over 10. Okay, and let's assign A, yeah, as an event of drawing the first green marble, and event B is equal to drawing the second green marble. Okay. The question is, what is the probability of drawing 2 green marbles without replacement? Well, the probability of selecting the first green marbles is just equal to 7/10. And since this is done without replacement, therefore, the probability of selecting the second green marbles is equal to 6/9 because the number of marbles has been taken out 1. Therefore, the probability of A intersection B, or often says probability of A and B, is equal to probability of A multiplied by probability of B after A, which is equal to 7/10 multiplied by 6/9, and that's equal to 7/15, or 0.4667. Now, this is similar to the conditional probability formula that you know. Yeah, this probability of B after A is just the same as probability of B given A, which is equal to probability of B intersection A. Remember, these two, they're just the same. Probability of B intersection A is just the same as probability of A intersection B. Okay, divided by probability of A. So what I'm doing here, I put this probability of B after A as a subject. Okay, and then you have the conditional probability. Okay, next is about the mutually exclusive event. Okay, let's consider throwing a dice. Okay, remember there's only one throw, and there are 2 events. Okay, event A is the probability of getting an even number, which is equal to 1/2. And probability of event B, yep, that means the probability of getting an odd number is just also equal to 1/2. And of course, in one throw, we cannot get both. We can only get an even number or an odd number, so we cannot have both. That's why it is called mutually exclusive event. Either you get A or you get B. Therefore, the probability of A or B is the addition of these 2 probabilities, which is equal to 1/4. Yeah, and to illustrate it using the Venn diagram, yeah, there is no intersection between these 2 sets. In this last part of the video, I will go through the union rule, or also known as addition rule, okay, which is probability of A union B, or A combined B, is equal to probability of A plus probability of B subtracted by probability of A intersection B. Now, this part here, subtracted by this intersection here, often confuses students. So I will try to explain why do we need to subtract by the intersection, and hopefully you will understand better. Okay, now before I continue to explain, I will ignore probability for now. Okay, I will ignore probability. I'll just focus on the number of elements in the set. Let A is equal to the number of boys play soccer, and B is equal to the number of boys play cricket. Yeah, and this is the scenario. In a total of 100 boys, there are 55 boys play soccer, okay, A, and 75 boys play cricket, which is B. And all boys must play at least one sport, meaning there's no boy, or there are no boys outside the circles. Yeah. So again, there are 55 boys in set A and 75 boys in set B, and we want to combine these two, knowing also there are 30 boys who play both sport. So again, we want to combine it. We want to uh, combine set A and set B. Right, so we have 55 boys in set A. Oops, sorry. Okay, let me leave the presentation first. Right, so again, there are 55 boys in set A, and 30 boys play both sport. So I will separate 55 into 25 and 30. Okay, similarly, I will separate 75 into 30 and 45, because there are 30 boys play both sport. Right, let me go to home. Okay, so let's combine these two sets and plug these numbers. Okay, I will put these two circles together until they intersect. Yeah, because there is an intersection. Now let's input these first. So 25 and 30. Okay, similarly with this one here, let's bring it closer. Let's bring 45 into the set B and 30 as well, but we put 30 here within this section because this is the intersection. Remember, the total number of boys has got to be 100, and here we have 30 plus 30 is 60, and then 25 plus 45 is 70. So 70 plus 60 is 130. So we are over by 30 because the total is 100. Here we have 130. The reason is that we are over by 30 because we consider, or we count 30 twice. Remember, intersex means belongs to both, yeah? So we have to take this one of these 30 out. Okay, so that's the reason why we have to subtract by the intersection. Now here we have 25 plus 30 plus 45, that gives us 100. So there you go, the explanation of why we need to subtract this intersection of A and B, right? Thank you very much for watching this video. I hope it helps.